Hello, my name is Robert French. I'm a 3D printing applications engineer with GoEngineer, and today we're going to talk about the Open Material License for FDM printers from Stratasys. The Open Material License is a new tool from Stratasys that allows users to really fine-tune how their FDM machines are going to run. Previously, we were limited to only the Stratasys preferred materials. These are materials made by Stratasys that we had very high confidence would run because Stratasys is controlling the whole process, but now we have access to validated materials. Materials from third-party companies that Stratasys has run enough hours on their machine to certify that they're going to have good results and produce high-quality prints. We also have now open source materials. Materials bought from any third party where the user can run through some trial and error and fine-tune parameters to run just about anything they can find. The process starts in the new OpenAM software. We're going to create a new material profile, and we can do so by cloning an existing profile or clicking Add to start new. This profile is going to be the set of parameters at which we will run whatever material we plan to insert into our machine, whether it be preferred, validated, or open source. We'll start by naming it, something reflective of the material, and perhaps a few settings we'll modify. And then we'll choose these accompanying settings. Our machine is the Fortis 450. That's all we can run the Open Material License on for now, but more will come. We're going to specify what material, the tip type, the slice thickness, support tip, so on. And we'll type in a few notes to make sure we're very clear about what we're going to be modifying. Once we've created our material profile, we will highlight it and click Tune at the bottom of the screen. This takes us to the Tuning tab, where we have access to all the parameters we're allowed to modify to run our material. Now we're going to go through these and perhaps fine-tune over several different prints in order to optimize whatever material we have loaded. It's organized into 5 main sections. Part, which deals with our actual model material, some temperatures surrounding that. Vertical, the different walls and how we'll navigate around the exterior of a part. The infill, such as sparse, double dense, things like that we've seen on previous FDM softwares like GrabCAD Print. We have the base, our kind of starting raft and the foundation upon which we'll build our part. And then we have support, dealing with the support nozzle, temperatures, and different parameters surrounding that. Now, we have different levels of complexity or how much parameters we're seeing down at the bottom here with display level. One is going to keep it very simple and some of the most commonly need to be changed parameters that we'll probably want to start with when we first jump into a new material. But we can bump that all the way up to 3 and see even more advanced parameters that we can really sink into and really fine-tune a print. In this example, you'll notice I named my material profile Hips plus 3 degrees. I'm going to focus on increasing the extruder and oven temperature 3 degrees Celsius and kind of see what that does to my print, whether it makes the print fail altogether, produces a little bit glossier and smoother surface. We're just kind of experimenting here, seeing what results will happen when I modify some of these settings, and kind of gives me some insight to fine-tuning materials in the future. Now, there are established limits, so you're not going to take it too far out of bounds and cause any damage to your machine. You'll most likely just get a failed print. Once I'm done fine-tuning my materials, I'm going to jump over to the Sets tab. A set is a group of material profiles and all their different tune settings that I'll eventually upload to the machine as a firmware update. This firmware update is basically telling the machine these are the new set of parameters that you'll run all of these different materials at. So I'll create my new set by first entering a name. Once I have the name entered, I can choose which material profiles do I want to add to this set. Now, the machine only knows how to run a material at one set of parameters at a time. So I can only have one material profile per actual material in a set. In other words, I can't have 2 hips profiles inside of one set, but I can have one for ASA, ABS, or any of the other different profiles. Now, once this profile is added and listed here in the set, I'm going to compile it. This is creating the firmware update that can be sent to your software that you're using, whether that be GrabCAD Print or Insight basically now adds those new materials in the drop-down list so you can choose to print them. And it's also going to send the firmware update to the machine so it knows to run at those new parameters. Once we've compiled our set, we'll see it listed here on the Packages tab. We're going to highlight our new package, choose which softwares we want to upgrade, and identify the machine we're going to push our firmware update to as well. We have to make sure that that machine is in license upgrade mode. Once it is, we can click the upgrade button down the bottom right corner. We'll see a series of progress bars. We'll also see an acknowledgement for the upgrading of the GrabCAD print software. And once that all is complete, we know we're good to go to start our print with our new updated settings. The final tab of the OpenAM software is the Compare tab. Now, I only changed 2 settings for this particular material profile, but as you start to change more and make more complicated changes, it can be tough to keep track of it. This tab gives a really quick, efficient breakdown of what settings you've changed within a material profile. That's it for this video on Open Material License and OpenAM software from Stratasys. I will be running this material profile as well as the base HIPs and several other HIPs profiles that I plan to fine-tune in the future, and I'll be adding other variables in like traverse rate, acceleration rate, and I'll be obviously looking at those in the context of part quality, print speed, and so on. Stay tuned for those videos in the future. My name is Robert French. Thanks for watching.